Okay, problem number 4. A 5-meter steel shaft rotating at 2 Hz has 70 kilowatt applied at a gear that is 2 meters from the left end, where 20 kilowatt are removed. At the right end, 30 kilowatt are removed and another 20 kilowatt leaves the shaft at 1.5 meter from the right end. Find the uniform shaft diameter so that the shearing stress will not exceed 60 megapascal. And letter B, if a uniform shaft diameter of 100 mm is specified, determine the angle by which one end of the shaft lags behind the other end. Use G, which is equal to 83 gigapascal. So for this problem, we have a figure. Of course, we have here our illustration. We have a 20 kilowatt was removed at point A, and there is an applied 70 kilowatt at point B, and remove 20 kilowatt at point C, and also there is a 30 kilowatt that leave point at this portion at point B. So we have to compute first for the torque at each point. So the formula, of course, is P all over 2 pi times F. So the value for the torque at point A and point C are the same. So we simply have to substitute the value for P, which is negative 20, and convert that one to watts. So times 1000 all over 2 pi times F, which is 2. And it gives us the value of negative 1591.55 Newton meter. And for the torque at point B, which is P is 70 times 1000 all over 2 pi times 2. So it gives us 5570.42 Newton meter. And the torque at point D is negative 30 times 1000 all over 2 pi times 2, which gives us a value of negative 2387.32 Newton meter. So for this one, if we're going to have the free body diagram for the value for the torque for each point, so we have here negative at point A, so we have negative 1591.55, so we go down, and then we try to have the value at point B, which is 5570.42, so we add 3978.87 Newton meter, so it goes up. Then at point C, we have negative 1591.55, so we go down. So we have a value towards point D, which is 2387.32 Newton meter. So we have now the value for our free body diagram. So for letter A, the problem is to get the value for the unknown diameter. So to get the value for the diameter, we simply have to make use of the equation for the maximum torsional shearing stress, which is 16T all over pi d cubed. So using that equation, so we simply have to substitute the value using torque for member AB, member BC, and member CD. So if we try to substitute the value for our T for member AB, member BC, and member CD, we get the value for the diameter, which is 51.33 mm. We have 69.6 mm and 58.7 millimeters. So for this, since we are after to compute for the maximum diameter, so we make use for the diameter the greatest higher in value, which is 69.6 mm. So this is the diameter that we're going to use, which is 69.6 mm. So that is the uniform shaft diameter. Then letter B, we are required to compute for the angle by which one end of the shaft lags behind the other. So what will be the angle of twist? So that's one. We make use of the equation PL all over JG. So from that formula, so we're going to have our angle of twist from D all over A. So that will be equal to 1 over JG. So we simply have to get the summation of TL. So torque times the length per member. So we have member AB, member BC, and member CD. So for this one, for our member AB, so the length of the shaft from that member is 2 meters. Then for our member BC, that is 1.5, and for our member CD is 1.5. So therefore, since that is in meters, we have to convert that one to so we multiply this by the value, which is 1000, since torque is also in Newton meters, so multiply also by 1000, so we get here 1000 squared. So if we try to simplify, we have now the value of the angle of twist, which is from D to A, so that will be 0.007813 rad, or that is equivalent. Convert this rad into degrees, so that is 0.448 degrees.